Okay, so today we are going to discuss the statistics paper number 2. Okay, so I am just sharing the screen. Is the screen visible? We are going to do this statistics paper 2, and I have the booklet set A with me right now. It's easily you can download it from the website itself. So I have booklet A with me of the previous year 2021, as you can see. So we are going to start. We are not going to do the sums serially, but we are rather going to start some with some arbitrary sums. Okay. So let us start with choose some of the arbitrary sums, and we are going to do this. Okay. Is the board visible?
Yes, ma'am.
Yes, ma'am.
Okay. So what do you prefer? Like I do the sum on the board or on this PDF itself?
PDF.
Okay, I'm doing it on the PDF itself. If the calculation is a little bit large, then I will actually do on the on the board or other than the rough pages given at the below of the PDF. Okay. Okay, let's start with this question number 2, and similarly, you can get the answer of question number 1. Okay, so for there is a model given. Can you identify the model? This is a model actually corresponds to one way ANOVA model, right? A model is given and it is saying that consider the following statement: mu plus tau 1, this is corresponds to alpha 1, some we have learned, or this is corresponding to the treatment, and this is the like constant term on the mu term, and this is eij other term. So we say that mu plus tau 1 is estimable or tau 1 plus tau 2 is estimable. So we want to like we have to detect that which statement is correct: only one, only two, both 1 and 2, and neither 1 neither 2. Can you tell me? Can I have an answer from your side? Can I have an answer from your side? Am I audible? Hello? Am I audible? Hello? Am I audible? Hello? Okay, I am showing you how to do this. The model is basically this. is yij equals to mu plus tau I plus eij, and I runs from 1 to j runs from 1 to. So let's fix I at 1, then and j at 1 itself. So it will be y11 mu plus tau 1 plus e11. Let's fix I at 1, j at 2. It will be y12 mu plus tau 1 plus e12. We'll be having another two terms, fixing I at 2, j at 1. That will be y21 mu plus tau 2 plus e21, and another term for I equals to 2 and j equals to 2, that is y22 is equals to mu plus tau 2 plus e22. So, is it possible to estimate tau 1 and tau 2 together? Actually, it is impossible to estimate tau 1 and tau 2 together, but we can estimate this mu plus tau 1 combination and mu plus tau 2 combination together. So, as per the question over here, we can estimate 1 over here. So, only 1 is my answer for this question. For question number 2, 1 only, that is option 1 is my answer. Clear?
Yes, ma'am.
Okay. Next, question number 3 is a wrong question. So please, drop this question actually. Okay, go for this question. Question number 11. X is a discrete random variable with probability distribution that this will take the value theta if x is minus 1, and it will take the value of this form 1 minus theta square theta to the power x if x runs from 0 up to infinity, where theta is a value lying between 0 and 1. So what will be this x is? Capital X is. Capital X will be minimal, sufficient and complete. X is minimal, sufficient only. X is complete only. X is unbiased estimator of theta. So as you can see, this is a split function, and the range is that x equals to minus 1 gives you theta, and for x equals to 0, 1, 2, 3, so it cannot be unbiased. Option D has been cancelled. And if you can try this out, actually this is a very big sum, but since we are concentrating on MCQ, so we want something which will help us to do it easily. Okay, so it cannot be complete because over the whole range it is not possible to be complete. So x, since x cannot be complete, so with option C we don't have option A itself with us, so it is only option B which is correct, where that is for 11, x is minimal sufficient only. This is my correct option. Is it clear?
Yes, ma'am.
Okay, next moving on to go for
13th
this
one.
sum. 13th. Let me check. Okay, this UMP test. Okay, this is a single sample is given. For x, the distribution is this. For y, the distribution is this. Okay, and for both the cases, the parameter theta is greater than 0, and the range, both x and y, ranges from 0 to infinity. So, what is the procedure of having a UMP test? Like, how do we test for that? We write this thing, na? like f of like x curl under h naught by f of x curl under h1 is less than 1. We take the ratio, right? Am I audible? Hello.
Yes, ma'am.
Okay, so here you need to assume that like for this particular thing, they said that this is for left tail test, this is for right tail test, again for left tail test and right tail test. So obviously you are going to take that you assume the testing problem like h naught theta equals to some theta naught against theta greater than theta naught or less than theta naught. You will be taking two cases. So under h naught there will be one distribution, under h1 there will be another distribution. Then you need to take the ratio of these two, and then at the end you will be getting expression whether this is x plus 2y or y plus 2x. That you need to calculate, either this will be greater than c or less than c according you have taken the left tail test or right tail test, and that is going to give you that whether this is sufficient or not, and whether the test has been taken as right tailed or left tailed. Like how we perform the UMP test, now you have to proceed in that way only.
Open. But here they give two functions. No.
Two functions, yes, obviously, because like for under each node there will be a one functional form, under each one there will be another functional form. Okay, let's go for question number 15. Let x1, x2, xn be IID random variable with density function this, where alpha is greater than 0 and x ranges from 0 to infinity. Obviously, you can see this is an exponential function. The uniformly minimum variance unbiased estimator of the parameter is, alpha is. So, UMVV, they are asking for UMVUE. So, can you figure out what is the UMVUE?
C, ma'am. Also.
C, absolutely correct. Because if you can see minimum variance unbiased estimator, obviously this nx, x by n and x bar by n plus 1 cannot be unbiased. Hence only option left is C. So even VV will be C itself, that is x bar. Okay. Next, moving on to, let's take question number 18. Okay, so T1, T2 are two consistent estimator of theta 1 and theta 2 respectively. Then consider the following estimators T1, T2. T1 plus T2 is always consistent, and T1 into T2 is always consistent for theta 1 into theta 2. And T1 plus T2 is consistent for theta 1 plus theta 2. So which statement is correct? Only A, only 1, only 2, both 1 and 2, neither 1 nor 2. Can you tell me this thing by using the property of consistency of an estimator?
Both, ma'am.
Both. Absolutely correct. Both 1 and 2. Because obviously the by the property of consistency we can actually answer these two questions. Like obviously if these are additive, the two statistic T1 and T2, these two estimators are additive. So it will be like consistent for theta 1 plus theta 2, and for T1 into T2 it will be consistent for theta 1 into theta 2. Okay, can you answer this question 31?
C में.
C. How you have got this?
मैं formula.
Which formula?
Mean deviation.
Okay, I'm just
Mean is
stating
0
for
over
the
here.
others. Okay, for normal 0, 1, since x follows normal 0, 1 over here, so we know that mean deviation about mean for normal is root over of 2 by pi into sigma for normal mu and sigma. So since here sigma is basically 1, so it will be root over of 2 by pi into 1. Okay, so mean deviation formula is expectation of mod of x minus mu, and my mu over here is basically 0, so that is nothing but expectation of mod x, and that is root over of 2 by pi. Okay. Next, let us do
39.
39. Wait, let me see. Yes, 39. CRLB. Okay, let x1, x2, xn be a random sample from Poisson distribution with parameter theta. Let the unbiased estimator of e to the power minus theta, which doesn't attain CRLB lower bound, is what are the options? Okay, so scroll down a little bit. Okay, I theta is e to the power minus theta, not I theta, sorry. My psi theta is e to the power minus theta. That implies psi prime theta is minus of e to the power minus theta, right? And since there are like n samples, so basically I theta will be what? Okay, can you tell me the formula of CRLV? They are saying that x1, x2, xn follows Poisson theta. So what will be my joint PDF, joint PMF f of x curl e to the power minus n lambda, lambda to the power summation xi by product over xi factorial, right? This is my joint PMF. Now I will be taking log of this thing, minus n lambda plus summation xi log of lambda minus log of product of xi factorial. Am I right? Then I will do a single derivative with respect to theta of this function. That is not theta, basically lambda over here is my parameter. So minus n plus summation xi by lambda plus 0. Then I can do a double derivative and take the minus sign. That is 0 minus summation xi by lambda square. Am I right? Just check whether my calculation is right or not. Is my calculation right?
Yes, ma'am.
Okay, then how can I find E theta minus of this del square del lambda square ln of f of x curl is going to give me summation xi by lambda square, and expectation of this whole thing minus del square del lambda square ln of f of x curl. That is going to give me 1 by lambda square summation over expectation of xi. What is expectation of xi for Poisson lambda? It was actually theta over here. I started with lambda. So let's change it to lambda. Since I started with lambda, so let's change it to lambda. Okay, so what is this expectation? That is n into lambda. So that is basically n by lambda. So what is the value of my I lambda? I lambda is nothing but this expectation of minus of del square del lambda square ln of f of x square. This thing, this is basically n by lambda. Then my CRLB is nothing but this 5 prime lambda and by I of lambda, and just you need to put the values. Put the values in terms of theta, not in terms of lambda. Okay. Okay. I hope you know the answer of this question 43.
Yes, ma'am.
What will be the answer? C. Because whenever we are writing this alpha less than x order 1 less than x order n less than beta, so basically we are taking up this bound, and the minimum of this alpha is basically x order 1, that is minimum of x1 x2 xn, and maximum of beta is maximum of x1 x2 xn, that is x order n. So that is going to be the MLE of alpha and beta respectively. Okay. Let's go and search for other questions. These are theoretical questions. We can leave these. Okay, can you answer question number 9? The same logic how we have answered the previous question.
C.
Can you explain why C?
Ma'am, here we can't estimate a single parameter like alpha and beta, but we can just changing
What
the
about
value of
this
5.
D?
Not estimate, not estimable, because we can't add. We have to add mu also.
Good. No. Mhm. Go for question number 20. Do this. Can I have the answer of question 20? Am I audible? Hello? Am I audible?
Yes, ma'am.
How you are proceeding for question number 20?
Ma'am, expectation of x is equal to x bar.
So what is the answer you have obtained?
Good. Point 2.
0.25. This is going to be the answer. So first you need to find the unbiased estimator from this particular distribution, geometric distribution in general. And if you can see that basically the like you said that if the expectation of t is equals to theta, and this t over here is basically my x bar. Since the observations is given over here, so I need to find the mean of this observation. From this I need to find the x bar. So and 12 observations are there, so obviously my mean will be 0.25, and which is my answer. Okay. Okay, can you answer question number 23?
Both.
Both. Can you explain?
Um, XN is MLE, but MLEs are almost consistent.
Not all MLEs, but for uniform 0 theta, if x order in is the MLE, that is first point is correct. So one is correct. So we are going to remove option B and option D. So from 1 and C, we can choose that xn is whether it is consistent or not. If we can see, yes, x order n is consistent. So obviously 1 and 2 is my answer. Next, going for okay, answer 24. 24 and then answer 26.
Both for 24.
Yes, absolutely correct. So it is very easy. And answer 26. Before you start 26, I was thinking of question number 13 and was trying to figure out basically an easier way how to do question number 13 as you asked me. So, can I repeat question number 13 once again? Am I audible?
Yes, ma'am.
Okay, so if you can see, like what we do for testing, I asked you the very first time that what we do for testing. Suppose we have x1, x2, xn, and we always write that IID, it follows some f of x, f of x. This is a functional form, PDF, PMF, whatever it is, and we take this thing like f of x curl and under h naught h1, and we take the ratio to be greater than 1, less than 1, based on the ratio, like we are taking h naught by h1 or h1 by h naught. Okay, and that's why how we proceed. Okay, and we assume that this x1 is a variable, x2 is a variable, xn is a variable. Instead of this x1, x2, xn, if I name the variable as xyz, there is no harm in it, right? So I have a variable x which is actually following the distribution. Basically, x follows some fx which was equals to, I think, exponential. This thing, right? And y was another variable which was following some exponential distribution like this, right? Okay, so now what will be the joint distribution in case of x1, x2, xn? We write x curl. So can I write the joint distribution? Sorry. So can I write the joint distribution like this? f of x comma y. So that will be nothing but, sorry, that will be nothing but fx into fy, since they are independently distributed. Obviously, they should be independently distributed, right? So that is basically 1 by theta e to the power minus x by theta into 1 by 2 theta e to the power minus y by 2 theta, where x comma y both greater than 0 and theta greater than 0. That is going to give me 1 by 2 theta square e to the power minus 1 by theta x plus y by 2. Now I am taking another step, just simplifying it. E to the power minus 1 by 2 theta 2x plus y. Can I write this?
One more theta.
Sorry,
Okay.
right? Okay. So now the thing is that after this thing, how we are calling, or why, what is the reason we call it to be sufficient, if it can be written as some g of t comma theta and h of x curl, right? Here h of x curl is basically 1, and this g of t comma theta is basically my this function,
Yes, ma'am.
where my this statistic t is my 2x plus y. So this t equals to 2x plus y is sufficient for theta. Can I write this?
Yes, ma'am.
Okay, now go to the question. Y equals plus 2x and y plus 2x. So we can easily exclude option A and B. We have only two options in hand, C and D. Now we need to judge whether it is a left tail test and right tail test. UMP test is given by this thing. Okay. So if I am testing for the obviously the parameter theta, then obviously if obviously what is my joint distribution over here, this thing, this f of xy, this is my joint distribution. So I will take the joint distribution, this f of xy under h naught and this f of xy under h1, right? I will take their ratios, and I am going to take two particular tests, like one is right tail test and one is left tail test, and going to see that which one is actually coming, that either this one, this y plus 2x is less than c, or y plus 2x is less than c for while taking this left tail test or right tail test. Then we can choose between this c and d. Is it okay?
Yes, ma'am.
Now is it clear how to get rid of this confusion of two variables?
Yes, ma'am.
Okay, so we were in question number 26. Okay, can you do question number 26? What's the answer for 26?
I'm not getting, ma'am.
Not getting? It's given x1, x2, xn follows some fx, which is 1 by theta into e to the power minus x by theta. Am I right? That is exponential. Okay. So f of x curl will be f of x curl will be 1 by theta to the power n e to the power minus 1 by theta summation xi. Log of f of x curl is log of 1 by theta to the power n minus 1 by theta summation xi. Del f of x curl by del theta is equals to let me write this. Okay, if I am taking log of a by b, so log 1 will be 0 minus this thing. So uh, minus n log of theta. No, wait. Log of 1 by theta to the power n, I can write this as log of theta to the power minus n. Then it will be minus n log of theta. Then if I do the derivative, it will give me minus n 1 by theta. Minus n by theta minus summation xi minus 1 by theta square. Then basically it is minus n by theta plus summation xi by theta square. So del f of x curl del theta square is equals to minus plus n by theta square minus 2 summation xi by theta cube. Is my calculation right till this much?
Yes, ma'am.
Okay, now taking a minus over here, del square f of x curl del theta square is equals to minus n by theta square plus 2 summation xi by theta cube. Now going for expectation of minus del square f of x curl by del theta square is, sorry, this is log of, everything will be log of. I have forgotten to write this log. So that is equals to minus of n by theta square plus 2 by theta cube summation of expectation of xi. What will be expectation of xi for this distribution?
Theta.
Plus 2 by theta cube into theta. So basically it is 2 minus n by theta square.
I meant theta.
Just 1 theta gets cancelled out. And phi theta is equals to theta gives you phi prime theta is equals to 1. They have asked you to find the unbiased estimator of theta, right?
Yes, ma'am.
So,
Ma'am, that should be n theta, like after
which
expectation. 2n theta.
expectation? Yes, it is n. Yes, it is n theta, right? You're absolutely right. It is 2n minus n, that is n by theta square. Is it okay now?
Yes, ma'am.
Okay, then what is my I theta? I theta is n by theta square. phi prime theta is 1. So CRLB is 1 by n by theta square. That is theta square by n. Do you have any option? Yes, theta square by n. Sticking over here. Is it okay?
Yes, ma'am.
Okay, now let's proceed and do some other thing. Okay, can you answer this one? Question number 25.
Ma'am, 2 is correct, but
Okay, if 2 is correct, so we can exclude this option and this option. So either it will be B or C. Now check about 1. Is CRLB always attends the variance, like CRLB inequality provides a lower bound to the variance of a sufficient estimator of gamma theta. Like, can CRLB always attends the variance lower bound? There was a sum which we were doing last, this sum and the previous sum of CRLB, which they have asked that CRLB was not attaining. So one is not always certain. So only two will be true, not C. Is it okay?
yes, ma'am.
Let's go for last sum. Okay, try 38.
Ma'am, all 3,
No, not all three.
but
Emily always unique?
no, ma'am.
Can you contradict with an example?
I mean,
Take
uniform distribution, 2 Emily's, ma'am.
uniform parameter.
Um, in uniform distribution, 2
Theta
parameters
minus
are there.
half, theta plus half.
Yes, ma'am.
This distribution. This is not unique, right? And
Yes, ma'am.
Emily may not always be consistent and obviously may not always be unbiased. So only 2 and 3. The last question, 35. Can you answer 35? 35 is very easy.
I'm only one.
Only one. Why not B?
Unbiased estimators are not unique. Many other.
Can you explain with an example?
I mean, normal distribution, mean, median, both are unbiased for population.
With a simple example, suppose I have some expectation of some t1 is equals to theta, some expectation of like suppose I have some, don't go for this, suppose x1 x2 xn or follows some normal theta comma 1. Okay, so obviously expectation of xi is equals to theta for all I, so all x1 x2 xn are unbiased for theta, so how can it be unique? And even I can go for expectation of x bar is as well as theta. So this is also another estimator. I can go for x1 plus x2 by 2. This is also another. If I take this, this is going to come out as theta as well. So I can form many unbiased estimators. So hence they are not unique. Okay.
Okay. I'm 39.
39. Wait. We have discussed 39 now.
I didn't get the solution. That one couldn't
We
solve.
didn't get this. This will be the answer. C.
Okay.
How much you have done?
I get confused between theta and e power minus theta. They asked for e power minus theta.
No, see, what is my CRLB? My CRLB is basically my phi prime theta by my I theta, right? So this
Okay.
phi prime theta, this phi theta over here is my e to the power minus theta. So phi prime theta will be what? Minus of e to the power minus of e to the power minus theta. So your CRLB will be minus of e to the power minus theta divided by that particular thing. And you need to find the unbiased, then the unbiased estimator v to the power minus theta which does not attain CRLB. You need to get the unbiased estimator v to the power minus theta. Sorry, you need to get the unbiased estimator. See the difference between these two questions. Where was the previous question? Yes, an unbiased estimator of theta. Okay, here the unbiased estimator was itself was of theta. Here it was the 9 you said, right. Here it was the unbiased estimator of e to the power minus theta. So you need to get that function as phi theta, which will be the unbiased estimator, which will be the unbiased estimator of e to the power minus theta. Okay. You need to get what is my phi theta. Then my phi theta is actually, let me write it again. My phi theta is actually UE of e to the power minus theta. First find this and then you proceed. Okay.
Okay.
Okay, so we have discussed many questions. Most are almost theoretical and some are like few are sum based. So I'm stopping over here today. So if you have any queries, you can post it to Sir's Query Center and they will be forwarding the queries to me. Okay.
Okay. Ma'am, can you share that vital statistics PDF, ma'am?
Vital statistics PDF. Yes, I forgot that. Right, wait.